still going over this. I got two more problems to go, and I want to get them over as quickly as possible so people like Asia can make sure that she has enough time to go through it. All right? Now.
I have a question.
Yeah.
Is third quarter going to be a lot of graphs and stuff again?
No. So if you guys look at this problem, again, if we're going to look into solving for our x-intercepts, again, going back to our understanding, the first thing we want to do is set what equal?
Can I try and solve it?
Y equal to 0.
Sure, y equal to 0. Go for it. See what you get. Go for it. And I'll check your answer. I'll look at it. Now, when we're looking at this, what we like to be able to do is we want to look into our first method. Do you guys kind of agree that solving using the square root method is just like what you guys learned at the beginning of the year, right? It should be fairly familiar with you. So would you agree that if you could solve every one of these like square root method, that would be nice, right? But we can only do square root method when we have one term that has an x. There we have two terms we have an x. You want to put it to the other side?
Is that what you have to
Well,
do?
tell me what to do. So put on 15x on the other side. I'm asking you. So then what do you do?
So 15x. Divide by 3. So now I hit the square root. There's your answer.
Well, the problem is we have x in the answer.
Take it out.
And we can't take it out. But you're on to something, though.
Oh, wait.
Are you serious?
Oh, I'm sorry. I was just listening to what he was saying.
Real notes. Was that wrong? Yeah, that was wrong.
So I'm sorry. I should have told you that I was just following along. I wasn't doing the answers. But listen to this.
That's going to mess with my...
Sorry. I should have said something.
With your what?
Erase it.
So,
Make it a nice color. Like, make it into a picture.
okay. Now, what Jake did was he went to solve for this, Molly, by using the same method. And what I said was, you guys, we can't use the same method when we have two terms. You can only use that solving method when we have one term. When we have two terms, we have to use a different method. And the method is what is called using factoring. Okay? You cannot use the same methods when you have more than one term. If you have one term, John, I don't understand what you are trying to do if you're trying to ask me that your grade is not acceptable and you're not changing anything. John, why have you not written anything down?
Let's just continue. Can you write something down, please?
No, there is no you're on some chapter and somebody else is on another
We're all in
chapter.
this together. We're all in this together.
John, take out a sheet of paper.
I thought we were about to hit those.
Take out a sheet of paper.
Why
'Cause
did
you
write
need
two
to learn
long
this.
directions?
What?
Well, then Asia, I'm sure will give you a piece of paper.
I'm about to roast you.
There we
Don't
go.
make me start.
Hey, this ain't for you.
Oh, good for you. So now we have 3x squared plus 15 plus 15x. So what we're going to do is factoring. When we're doing factoring, what we are doing is we are rewriting an expression as multiplication. Really, you're rewriting it as a product of two terms. So what I want you guys to understand, do you guys see right now, Jazeel, that we have two terms, right? Of these two terms, and Jazeel, things are not changing. Some things are not going to change, guys. You can try and think as much as you want, but things are not going to change unless you're making that change. You have two terms. Right now, these two terms are separated by addition. Do you guys agree with me? If we can factor this, once we factor this, we are going to be able to rewrite the expression as multiplication. So how do we factor this? Well, the first factoring technique that I'm going to tell you guys to use is called factor out the GCF. And what the GCF means, again, is the greatest common factor. Okay? That means the greatest factor. That factor is something that divides into a number or term. So the greatest number that divides into both of these terms. So we look at these separate terms, and we say, what is a number or a term or a variable that divides evenly into both of these terms? Let's look at the numbers first. Renee, first number would be 3. 3 is the largest number that divides into both of them. Jacob, what about variables? What variable would you say can be divided into both of those? Well, 3 is the number. What variable? Variable letters. X. Can we do x squared or just x?
X squared.
Well, remember, it has to be divisible. Can x squared divide into x? No. So the largest term that divides into both of them is just x. OK? Guys, it's very obvious why some of these grades are where they're at. Seriously, you have to be able to buckle down and zone in for these 5 minutes. We are probably taking an extra 10 minutes for this when it should have already been done. Yes? Yes, absolutely.
This is the easiest thing we've done.
So when you're looking at your GCF, you want to find the factor that divides into both of them. Does 3 divide into 3x squared? Yes. Does 3 divide into 15? Yeah, so you want to find the largest number. The only numbers that divide into 3 are 3 and 1. So I can't say that there's any larger number than 3, right? So 3 is the greatest factor that divides into these two terms. X is my next term. X divides into x, and x divides into x squared. OK? But I can't say x squared because x squared doesn't divide into x. It only x is the largest one. So this is the largest number or term that evenly divides into both of them. Would you agree with me? OK. So what we do to factor out our GCF is we divide both of our terms by our GCF. OK? So you identify the GCF, and you divide both terms by the GCF. When you do that, you now, remember I said, guys, I'm not getting an answer. When we're factoring, all we're simply doing is just rewriting the problem as a product. So you're taking what you divided, your GCF, and you're going to divide it out, and you're going to multiply it by the quotient, which is the answer of your division. So 3x squared divided by 3x. How many times does 3 get divided into 3? Once. How many times does x divide into x squared? Well, x times.
So x squared?
It's just x. X divides into x squared x times. 3 divided by 3 is 1, which I'm not going to write the 1. OK?
But wouldn't it be plus 5?
Plus 5x.
Yeah.
Watch.
Okay. That's how you finish it. Then.
Molly, could you find a new seat, please? OK. Do you agree with me that 3x squared can be rewritten as 3 times x times x?
Yeah.
OK. 3's go to 1. X's go to 1. Oh, I'm going to explain that in a second. I'll explain that. No, well, that's what's left over is x. So I put it inside the parentheses. I'm going to explain why this works. But you take your answer. 3x squared divided by 3x equals x. Plus, what 15x divided by 3x is what? 5. Just 5, because the x's are going to divide to 1.
Wait, they didn't.
15x divided by 3x. 15 divides by 3 5 times. X divides into itself, so it's just left with 1. That's where I left with 5. Now, again, what I did was I found my GCF. I divide both terms by the GCF. And then I rewrite it on the outside of the quotient. Molly, I asked you to find a different seat. Please find a different seat. So how does that work, Jaziel? Remember what I said about factoring. All factoring is rewriting an expression as multiplication. Is this the multiplication? Yes. It's 3x times this. Now, if I were to multiply these two, would I get back my original expression? Right? Apply distributive property. 3x times x is 3x squared. 3x times 5 is 15x. So what you guys see, hold on one second, is when I take this and I multiply this times this, I get back my original answer. Do you guys agree with me?
So that's
It's not the answer. It's not the answer.
if it's not
So
the answer, then why did we even do that?
So now what we have done is we have factored the expression. The purpose of factoring the expression is to rewrite it as a product. Why would we want to rewrite it as a product? Why do we want this as multiplication? Because remember, we can't solve using, everything would be easier if we could solve using the square root method. We can't use that method in example 1. We have to use the factoring. The reason why is because now we can use the zero product property. And what the zero product property states is when you have two numbers that multiply to give you 0, then one of them has to equal 0. The same thing, when you have two expressions that multiply to give you 0, one of them has to equal 0. So I have this times this equals 0. That means I can now set both of these equal to 0. And now I can solve. Sorry. Now you guys can see I have two answers. And is it possible from looking at what I originally